Alright guys, today we're going to be looking at what to do when you're faced with a combination of exponent rules. The combination of exponent rules we're going to be looking at are the product property, the quotient property, negative exponents, exponents of zero, and the power rule. So in each of these examples, there are three of them. There are multiple ways you can get started. It's kind of up to you what you want to do with this. Me personally, I would try to move any negative exponents either up above or below just to make them positive and then work from there. So that being said, I'm going to move x to the negative fourth down so that it can become positive. So I'd have negative x squared times negative 2y to the fourth over x to the 0 power raised to the fourth times x to the fourth. Now, next, x to the 0 power is going to be 1, and 1 to the 4th power is going to be 1. So realistically, we can get rid of this entirely. I have the negative 1 out front, and this negative but next to the 2 will cancel each other out as well. I have x squared over x to the fourth. That means I need to subtract those exponents. So x to the 2 minus 4 power times 2y to the fourth. And then x to the 2 minus 4 power becomes x to the negative 2 times 2y to the fourth. I'm going to need to bring this down into the bottom of a fraction. So in the top of my fraction, I will have 2y to the fourth, and in the bottom, I'll have x to the second. There's nothing else to simplify or to move, so that's my answer. Again, it's up to you how you start these. I just like to move my negatives around so that they become positive and I don't have to worry about them. In this next example, example 2, I have this entire parenthesis to the negative 1 power, so I'm going to move it down. The negative 1 power will become positive. I'm also going to move this set of parentheses raised to the negative 4 power up so that it becomes positive. The last thing I'm going to move is this a to the negative first down again so that it becomes positive. So what I'll have when I do that is 2b to the fourth will still be in the numerator. It hasn't moved. Then I have negative a squared b squared raised to the power of positive 4. In the denominator now I have 2a to the third, b to the second. There's no need to put this in parentheses and raise it to the power of 1 because raising it to the power of 1 is not really doing anything. So we're just going to go ahead and get rid of it. From here, I notice that these 2's can cancel out completely. If I distribute this power of 4, remember there's a 1 attached to that negative. So it's going to go to the negative 1, to a squared, and to b squared. This becomes b to the fourth. Negative 1 to the 4th power realistically is going to become 1, so I really don't need to write that down. And then I have a to the 2 times 4 power, which becomes a to the 8th, b to the 2 times 4 power, which becomes b to the 8th as well. In the bottom, I'm left with a cubed b squared. When I multiply like bases, I'm going to need to add my exponents. My like bases are b to the fourth and b to the 8th. This is going to become b to the 12th power and a to the 8th power. And I'm going to readjust so that I can line everything up. B to the 12th over b to the 2nd is going to become b to the 10th. And a to the 8th over a to the 3rd is going to become a to the 5th. In this last problem, I have a negative and a negative in the numerator. That's going to become positive. My numbers that need to, or my pieces that need to move are this x to the negative third, y to the negative third, and x to the negative fourth power. They all need to move. And y to the 0 is going to become 1. Y to the 0 down here is going to become 1 as well. So I'm just going to go ahead and move what I have. In the numerator, I'll be left with 2x. In the denominator, I have x to the third, y to the third, x to the fourth, and then I still have in parentheses x to the negative 1 raised to the power of 3. If I distribute that power, I have 2x over x to the fourth and x to the third and x to the fourth become x to the seventh. I have y to the third, and I have x to the negative 3 power. If I combine my x's, x to the seventh and x to the negative third become x to the positive fourth. And then if I subtract my exponents because I'm dividing, this leaves me with 2x to the 1 minus 4 power over y to the third, which will be 2x to the negative third over y to the third. And if I bring this down to make it positive, my final answer is 2 over x to the third, y to the third. Alright guys, that was a combination of exponent rules. Have a great day.